all, we should know what is decision tree. Okay. So in a decision tree, there will be edges and nodes. Node will be the condition on which the data is splitted, and edge is the direction in which the data is going. Basically, edge is nothing. Right? Basically, it shows the path in which it goes. Right? So condition is the main thing. Right? Basically, we are looking into classification problem now. We are trying to split data into two parts. That's what we're trying to do. Either it is um, SVM or logistic regression. So here, based out of conditions, we are going to do it. You take a column. Right? That column will actually distinguish data between two classes, 1 and 0. Right? So you take the most prominent column first, and then split the data on it, and then take the next column and try to split it. Next column, try to split. You do the split until the leaf nodes become one class. Okay, if one condition satisfied an xk, right, xk is the kth column, and we come this side. Right? If it is yes, we will come this side. If it is no, we'll go this side. Or yes, you will go this side. No, you'll come this side. Again on xi, we will try to see another condition. We'll go, if it is no, we'll go this direction. If it is yes, we'll go this direction. By using the existing conditions, we'll try to predict whether the class belongs to 0 or 1. Let me reiterate. You have 1000 records, and you found out, using those 1000 records, you found out the conditions to make data distinguished between 0 and 1 class. You are using those conditions to predict on a new record. 1000 records are used to find out these conditions. Right? Once you know the conditions, you take the new record and pass it through these conditions and find out which category it belongs to. That is the prediction we are going to do. Got it? Decision tree, how it works. Did you get it? If you understand this part, right, I can move on, because the major part in decision tree is to understand how is it chosen xk as the first node and xi as the second node, xj as the second node. But which one to choose as the first node, which one to choose as next node? That is the key in decision trees. Did you understand basic idea?
Yes, sir.
Yes, sir.
So you should remember this. Okay, we have train set, right? 1000 or 1 million records. By looking at the train set, we are understanding the conditions on which column we should be splitting data first, then on which column, then on which column. By the time we do n number of conditions, we get leaf nodes. We call these leaf nodes belonging to a single class. No, maybe there are 100 records here, maybe there are 500 records here, maybe there are 300, maybe there are 200 records. All records belong to one class. So using those 1000 records, we actually found out the conditions to split the data. When a new record comes in, we pass it through the conditions and predict, which class it belongs to. Okay, that's the key. The 1000 records are used to find out these conditions. But how did the decision tree decided xk as the first condition need to be splitted? Xi is the first condition, the second condition need to be splitted. And xj is the third condition need to be splitted, is the big question. So there is a math involved in finding out the best feature. This is the best feature out of all the features. That's where we chose that as the first split. How do you decide whether a feature is the best or not? If that feature has got more distinctive power, we are trying to dissect or divide the data set into two classes or maybe n classes. You can have n classes also. I have, for simplicity, I have taken two classes only, but you can have n classes. So how best the feature is dividing the data into two different classes, decides which feature is the best feature. In a way, the order of the columns on which the conditions are applied is the order of the best, the best feature also, right? The feature selection. Right? So using the math involved in decision tree, we can find out the best features. This is the best feature. Next best are these. Next best are going to be down below. Now, if the tree is bigger, you will have more. Okay. So using a data set, right? Now we'll see how exactly the split is happening. Okay.
Sir, one question, sir.
Yeah.
You mentioned that the currently condition belongs to one column. So there is possibility that the condition can be based on two columns together also, right? Possibly.
No, no. In decision trees, it is always based on one condition, one column.
Okay.
When we look at the math, right, you'll understand.
Okay, sir.
The basic idea. Maybe, some kind of research should happen on the lines you are actually talking about. Maybe in future we'll get those kinds of algorithms also. But now it is based on one column only.
Okay, sir.
So, I think that, if you look at this 1 and 0, that is based out of this column and this column condition. It's a combination, and condition it is. This column, this condition and this condition led to this place or this place. The decision made as 1 or 0. That's already there, I think.
Okay.
So, decision tree algorithms are known as divide and conquer algorithm. We are going to split data. Right? We take 1,000 records, split them into maybe 600 and maybe 400. And again, based on some condition, we will split into 100 and 500. Again here 200, 300. Like that, we'll split the data. Divide and conquer is the algorithm.
Sir,
Node, yeah. Go ahead.
Actually, I missed the last maybe 5-10 minutes.
Okay.
Can you quickly?
Sure. No, decision. Yeah, please. Yeah, that's fine. Decision trees divide the data into sub.
Sir, I lost your voice.
Yeah, we also same. We also lost.
Oh.
Can you hear me? Hello.
Yes, sir. Now we are able to hear you.
Yeah. I had we have power outage here. Just I connect through mobile now. So yeah, the thing is, decision trees will basically divide data and try to understand which category the record belongs to. You may get a train set of 1,000 records or 1 million records, or maybe you cannot handle 10 million, because decision tree actually being formed in memory, and memory may not be sufficient to form it, right? So if you have maybe 1 million records or maybe 100,000 records, you look at the 100,000 records and see which column is the best column to decide the class of the data. Based on that, you split the data. Maybe 100,000 records, you split it into 60,000 and 40,000. And then based on other column, XK column, we made the split. Based on other column, a condition, which splits the data into maybe 100 and maybe 500, which 100,000 records, 10,000 records and 50,000 records. The 10,000 records belongs to one class and 50,000. Ultimately, the tree's goal is to split data in such a way that the leaf nodes belong to one class. One of each leaf belongs to one class. That is decision tree. Okay. Now the nodes test the
Yes, sir. Go ahead, please. No.
Anyway, we are going to talk about this only in more detail. So decision tree will have nodes, right? These nodes that test the value of a certain attribute. Attribute or column or feature are all synonyms, right? Test for a value. It's a condition, if condition it is. greater than or equal to, less than or equal to, on a particular column for a value. Okay, and then connect the next node or leaf, depending on the if it is the last, right? When I say it is last leaf node, when all records belong to one class, then I say it is a last record, last leaf node. Leaf nodes, so terminal nodes that predict the outcome. Okay, so when a new record comes in, right, you pass through the condition. If xk less than something, it comes here. Xk greater than something, it goes there, and xi greater than something, it goes there and predicts that the record belongs to 0. So how exactly these features are being selected, or the tree is being constructed, we need to understand. The next point is decision tree models are non-parametric models. What is parametric model? Linear regression, logistic regression, SVM, these are all parametric models, because if you have n number of features, there will be n plus 1 number of coefficients. Okay, theta 0 to theta n, right? The parameters are known. The number of parameters are known beforehand. But in decision tree, right, you don't know how many splits it will happen and how many leaf nodes you will get. This is called a non-parametric model. So non-parametric models are tend to overfit. That's a statement you need to remember. Non-parametric models tend to overfit on trained data. Okay, I'll explain this why and how can we actually avoid this overfitting by using ensemble models. And one more statement I'll make. Two statements I'm going to make. One, decision tree models are going to overfit on train set. Okay. And the second thing is decision tree models are not directly used in any project. Okay. We use ensemble models which are built on top of decision trees, or the decision trees to get better results. Okay. These are the two statements you need to remember. I'll explain why and how and all that. Okay. So decision tree models make few assumptions about the training data. Right? It can actually handle nulls and independence and no assumptions basically. Right? It can handle nulls also. Let us look at a data set and see how exactly the split is happening. Then we will go into the other details. So classification, we are looking into a classification problem now, and tomorrow we'll look into a regression problem. Split into subsets. The first step is to split the data into subsets. When I say subset, rows, not columns. Okay, so there are 14 rows here. First split will make maybe 5, 5 and 4 kind of split. Okay, then again check is that the split is pure. When I say pure, all the records in the split are belonging to one class or not. If it is not, then again apply the split onto the impure subset and repeat this until you reach to a pure subset. Let me show you. This is the data, and this data is about whether people are playing tennis or not. Okay, when it is sunny, hot, high, weak, right? Wind is weak. People are not playing. Okay, temperature is hot and humidity is high. People are not playing. Okay, sunny, hot, high, strong, no, right? Like that. When a new day comes in with some, the outlook, temperature, and humidity and wind, we need to predict whether people are going to play or not. Right? That's the problem. So let us look at how the split happened here. See this? On Outlook, we made the first split. Why Outlook? I'll explain in a moment. Right? If you look at these three splits, the second split is pure. You can see, I hope. Right? I am saying second split is pure. First one and third one are not pure. Not impure.
Sir, when you say pure, it's belong to same class. Is that correct?
Yes. Right. So basically, what it means is on a certain day, the outlook is sunny, right? So Outlook is overcast, right? Definitely they'll play. No need to look at other columns. Okay, so decision is made here, right? It is yes, it is saying by looking at the train data, it is saying yes, right? So if it is sunny or rainy, we need to look into other columns also. Okay, so this is the best column that can actually make a decision, right? In a single shot, it can make a decision on some kind of records. Right? There are three categories in Outlook: sunny, overcast, and rain. Right? If it is overcast, it is actually making a decision. Right? If you look at other columns, right, they may not be able to make this clear decision. If you look at temperature or humidity or wind, right, they don't have a category that actually can make a clear decision on at least one category. At least one category. That's where this feature is very good. That's where we took this feature as the first condition. Right, Outlook is equal to, right, overcast. Outlook is equal to sunny. Outlook that's a condition on this particular column. And this is the best column I'm saying because it is able to make some decision, right? So whichever column has got the highest predictive power, whichever feature or whichever the column is the most important feature, we'll make split on that particular column. The math tries to find out the best column. We will see into the math later. Okay. Now the first split happened. The second split, I'm going to take this part, and then apply the math and going to make a split there. See this?
Sir, one
First
question,
split.
sir. Sir, one question. So you actually did this classification based on some initial split. Is that correct, sir?
So your question is, how did you choose Outlook as the best column?
Yeah, for that you need to make a split and then you look at whether that column is pure or not.
No. There is a math involved in this. I'll explain. Gini
Okay.
index and information, gain are the mathematics involved in there. Probability is involved in there, right?
Oh,
I'm
okay.
theoretically trying to explain first, and then I'll go into math.
Okay.
If I go into math directly, right, you may get confused. So how this is chosen, right? Out of the four features, how this is chosen is the question. The decision tree algorithm is answering. We'll know how exactly the calculation is happening also, but that is not really needed, to for our coding, whatever, right? To build a model, right? How this math is working is not really needed, but theoretically you need to have that impure node and pure node. I am trying to explain. Right? Impurity is what is the measure. The highest the impurity, the low the impurity, that's the best feature. Okay? We have mathematical techniques to calculate impurity. Based on impurity metric, the data is being splitted to pure node or impure node. Okay, so these two are impure and this is pure. There is no need to split this. We'll take this and split it again. When you have to split that node, you need to find out of this data, on this data, which feature can actually make a clear distinction, right? Already we made a split on Outlook, right? And Outlook is sunny. For all the records, it is sunny, right? No, we will not be able to make a split on that, right? For temperature, humidity, and wind, we can make a split. Out of these three, which one is good? Right? If you look at temperature, there are hot, mild, and cold, three, right? But there are, hot and mild, two are actually falling into no, and cold and mild, two record. So it is unable to split. But the high is all belonging to no, normal and the humidity are belong to the S, right? So I made a split on that humidity because it can clearly distinguish and create pure nodes here, right? Now a new record comes in. A new record comes in with sunny in the Outlook, humidity high, right? You go this direction. If the new record comes in with Outlook, uh, uh, Outlook overcast, and then temperature something, humidity something, wind is something. You don't care. You directly come here, predict that they are playing yes. Okay. If it is sunny, the record comes with sunny, and in the humidity you have high or normal. You go this direction, you make prediction yes or no. Okay? Now, based on this existing training data, I found some conditions and formed a tree. Using that tree, I'm making predictions when a new record comes in. Okay. Now I'll take this particular, impure subset. Again, I try to find the best split. In this, right, when I try to find temperature and wind, humidity is made here, or you can actually check humidity also, this side also. But humidity is not the best one. So temperature and wind is the best one, because on weak wind, people are playing. On strong wind, right, there is another feature also, there is impact. This is impure node still. So I need to do more math and then, find out. Even this is impure, right? I am doing more math. So this is the ultimate tree, right? This is the ultimate tree. So if you ask me which is the best feature out of all these features, right, I'll say outlook is the best feature. Then humidity is the best feature, because outlook is clearly, making a split, and humidity is clearly making a split, right? Then the best feature is wind. Then the best feature is, you know, temperature. Then the best feature is humidity, right? Like that. You can, by building a decision tree, you can find out best features. And decision tree actually assigns some score to each of these features. I'll show you. Decision tree method has decision tree algorithm has got a attribute called as important underscore features underscore an attribute that gives you scores of all these features. Okay, you sort the data, in the descending order of the scores, you get best features. Okay, so that is the theoretical understanding of decision tree. Any questions here?
Sir, 1 second. Regarding once the sorting is done, which finalizing what is the best feature, can you please repeat that once again? Finalizing of the best feature in this example.
So first split, on which column we have made the split is the best one out of all. Second best is this one, because whichever feature clearly distinguishes the data into two subsets is the best. See this here. If you look at humidity, it clearly distinguished. But if you look at wind, it distinguished one part, but the other part it is not clearly distinguished, right? So it will assign a little higher score to humidity than wind. Right? This
Okay,
is the highest score. This is a little low, little less score. This is even less score. Right? This is even less score. Temperature is even less score. Then humidity is, least feature.
okay, sir.
Like that it is. So we will see that. Practically we will see how exactly we can get it. This is all done internally by the decision tree, but how it is done, I am going to explain now. Basic idea you got, right?
Yes, sir.
So now, right, I have taken three records here. Right, I have taken the original data, the training data, and formed a tree. Right. Now this tree is available to me to make predictions. I have taken three records: outlook sunny, temperature cool, humidity normal, and wind weak. How will I make a decision? Right. Outlook is sunny. Right. I will go this direction, and then humidity is cool, right? If I come here, next feature I need to look at is humidity. Right? Humidity is normal. Right? Humidity normal means they'll play, right? This, the decision is going to be play, right? Yes. And the second record, outlook is rain, right? I'll go this direction. Then I need to look into wind, right? What is wind? Where is wind? Okay. Wind is strong. If it is strong, I'll go this direction, right? Now I need to look into temperature. Temperature is mild, right? I'll go this direction. right, mild this direction, and then I need to look into humidity. Humidity is normal, right? So yeah, humidity will get highest score, and the temperature will get the least score, something like that. Humidity is here. Again, we are using the same feature here to make prediction. Humidity is normal, so they are going to play. Okay. So for the second record to make a decision, I had to traverse all the way, till this place. Okay. Sometimes the traversal takes little more, nodes to be touched than some other times, depending on the data. Okay, let me take the third record and try to make prediction. No, outlook is rain. Right, I came this direction. Wind, wind is strong. Right, I came this direction. Now I need to look into temperature. Temperature is hot. Do I have temperature hot here? Do I have temperature hot?
No.
No, right? Algorithm will not be able to predict. Right? What do you call that situation as? Overfitting? Right? You call that
Yes,
as
sir.
overfitting? Right? This is unknown data, the test data. On test data, the algorithm failed to make prediction. But train data, if you take train data, any record from the train data set, will you be able to make prediction 100%?
May not be, sir.
On train data?
Yeah, may not be, because there are some cases where we got mixed results also, right? When we are coming with the decisions, some are not pure in this
But
categorization.
the tree was made using this train data, right? We will be able to make predictions on all the records which are present in train data.
Yes, sir. We can get
Yeah.
100%.
100%, because the tree was built using this data. Right? All the conditions we found out based on this data only. So it covers all the scenarios in the train data, but it will not cover the data not present in the train set. Some cases it will not cover. That's where non-parametric models like decision tree tend to overfit, especially when you try to form complete tree like this, right? It's going to tend to overfit on the train data. Got it? Got it. I'm actually trying to show you the overfitting issue with the decision trees. Any questions? Any questions? No. So I need to explain one more thing here. So this can be solved using ensemble models. Okay. It is not the end of the world. Right? We can solve this problem using ensemble models, but this is the decision tree is a building block. It is not the end solution. Okay. So if in interviews, right, if somebody asks you, did you use decision tree in any of your projects, you should say no, because decision trees are always tend to overfit on the train data. Okay, let me try to take a screenshot of this and explain something more. So here, if you look at this column, there are sunny, overcast, and rainy. Right? Outlook has got 3 distinct values. Right? And the temperature, hot, mild, and cold, 3 distinct values. And the humidity, high, normal, 2 distinct values. And wind, weak, strong, 2 distinct values. So total number of combinations I can get, or total number of records, right? The distinct records I can get are going to be 3 into 3 into 2 into 2, right? 36. 36 distinct combinations I can get. They may repeat, right? On a certain day, you may get same kind of situation, same kind of, overcast, cool, normal, strong. Do you agree? This 36 thing, do you agree?
Yes, sir.
Right? We have 14 combinations only here, right? Out of 36, we have 14 combinations only. And we formed a tree using those 14 combinations only. But if you get one of the combinations that are belonging to those, 22 combinations, the algorithm will fail. The model will fail. Okay, that is overfitting. There is a possibility to get some combinations. You will not get all combinations because when it is hot and sunny, you will not get rain, right? So some of the combinations you will not get. Maybe the situation I created may be hypothetical and it may not be possible also. Let me see that. See here, rain, hot, normal, strong. Okay. Maybe rain, hot, humidity is not going to be there. Humidity is going to be low, right? Wind may be strong, but humidity is going to be low, right? So that way, the data I created may not be right, but I'm actually creating a synthetic scenario that actually explains the overfitting problem. Okay, decision trees are tend to overfit. Okay. So if you understand these concepts, right, I'll go into the math. Go ahead.
So what is that 14 and 22?
So there are three distinct values, right, in the outlook.
Yeah.
All right, and like this, if you have let me try to take sunny and overcast. Suppose that only and in only two categories are there in outlook and two categories are there in temperature, right? Hot and mild. How many records we can get? How many combinations we can get? Like this, right? Right?
4.
Sunny hot, sunny hot, sunny mild, right? And overcast hot, overcast mild. Like that, right? There are three distinct values in outlook. There are three distinct values in temperature. There are two distinct values in humidity, two distinct values in wind. Total number of combinations you can get are 36. Total number of distinct records you can get are 36. Do you agree?
Yeah.
Right? But now we have 14 records only here. Right? These are 14 records only. 14 days we are taking. All 14 are distinct. Okay. But there are 22 combinations that were not covered in this data, in this training data. Do you agree?
Yes. Yeah, you are.
Maybe those 22 combinations are not possible practically, right? Because when it is sunny and hot, you cannot get rain, right? So some combinations out of these 22 may not be possible, but maybe, there may be 3 or 4 combinations which may be possible, which may occur in production or test, right? On those records, the model will fail because the tree built is using only 14 combinations. For all these 14 combinations, this model will work very well. For the missing 4-5 combinations, the model may not work. That is called as overfitting. Got it?
Yes, sir. If in case like it can be calculatable, like whatever we got 36, and if there are rows which are actually covering all the combinations, then
model will work 100% right.
Yeah.
Even in production you can use. Yeah, even in production you can use decision tree when your train set covers all combinations.
Okay.
But practically that is not possible because data is ever changing, right? The patterns are ever changing. And there is another problem with decision tree. If you change, 4 or 5 records here, if you add 4 records or remove 4 records, whole tree will change because the combinations will change, right? Right?
Yes.
So when new data comes in, right, the tree will change, the structure will change, decisions will change. The previous decisions made up will also change. Right? So those are the problems with the decision tree. If you understand theoretically how decision tree works, now I'll go into math. Not needed that much, but we'll understand it a little bit. How exactly the algorithm is choosing the best feature. But in interviews, some interviews they'll ask how is the math happening? What is cross entropy? What is Gini gain? What is Gini index and all things like that. Can I move on?
Yes, sir.
Okay, thank you. Now, right, to split the data into a tree, there are two approaches. One is ID3 and another is CART. Okay, so ID3 is an algorithm which actually does multi-way split like this. CART algorithm does binary split only. CART algorithm's condition is going to be outlook is equal to sunny. That's the condition. If yes, it will go in one direction. If no, it will go in another direction. Okay, outlook is equal to overcast. All the SS will come to one side, and sunny and rain all records come into other side. Again, you will apply. Is outlook is equal to rain or sunny. Right? Again, you will make split. That is binary split only. CART algorithm does binary split only. ID3 algorithm does multi-way split. And in the scikit-learn implementation, it uses CART. But I am explaining Outlook, the ID3 because it is easy to explain. Okay, if I do CART, right, there will be more number of layers, right? The tree height will increase a lot. Okay, so explanation purposes, it is easy to explain. So I took ID3. Okay, so in ID3 it uses Gini index. Okay, to find out the best feature. Okay, there are two different things you need to calculate. Gini index for the target variable and Gini index for the input variables. Basically, we are trying to decide which feature is important. Gini index for input variable is enough, but there is a concept called a Gini gain that tries to subtract Gini index of the input variable from the output variable. Okay, I'll talk about Gini gain a little later. Let us look at Gini index. There is a formula to calculate Gini index. Okay, don't look at this formula, it's going to be a bit confusing. I'll show you the actual implementation here. Okay, so Gini index for outlook, probability of sunny into probability of yes given sunny, probability of no given sunny, plus probability of overcast into, right, there are three distinct categories in outlook. For each of the category, we are calculating probability of belonging to yes and belonging to no, and probability of that individual category also, multiplying them, right? And again for the second category also and third category also, and summing up. That's how the Gini index is calculated. Okay, so this is the formula here. Probability of P of V means the distinct category, right? Sunny, okay, and overcast and rain, into probability of I given V. I is the class, right? The target variable, right? Distinct classes categories in the target variable, yes and no. Yes given sunny, no given sunny. We need to. This is called as conditional probability. Okay. Yes when it is sunny, no when it is sunny. Okay, I'll show you how exactly what is the probability there. Probability of sunny is 5/14. Why? If you look at this data, out of 14 records, there are 5 records belonging to sunny. 1, 2, 3, 4, 5. Total number of events So favorable events divided by total number of events. Favorable events are 1, 2, 3, 4, 5. Probability is ratio, right? Probability is ratio. Probability of sunny is 5 by 40. Probability of sunny, yes given sunny, right? What we want to see is when there is yes, right? When it is sunny, how many times it is yes? When it is sunny, how many times it is yes? When it is sunny, these two are sunny, these two are sunny, and this is sunny, right? Is this yes here? No. One place it is yes, another place it is yes. Out of 5 times, 2 times it is yes. 2 by 5. Got it? It's conditional probability. Understanding, the probability is important because in NLP, again, we'll actually, in NLP, the natural language models, we call them as, like statistical models. In there, we'll use the same probability. That's it. No more than what I'm explaining right now. Okay. If you understand this part, that is good enough. Okay. So here, probability of sunny we are trying to find. There is no condition here. But here there is condition. I want to find probability of yes only when it is sunny. Probability of no only when it is sunny. If I say what is probability of yes, can you tell me how much it is? Naranga. Probability of yes, no condition. Probability of no, no condition.
For sunny, sir?
No, no condition. Only yes, only no. Probability of yes and probability of no. Can you tell me?
1, 2, 3, 4, 5. 5 by 14, sir.
5 by 14 is for probability of no.
No.
1 minus 5 by 14 is going to be probability of yes.
Yes.
Okay. So total probability is going to be 1. Total probability of no plus probability of no plus probability of yes is equal to 1. Okay. So that is probability. Okay. And probability of yes is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by 14. When there is no condition. But when there is condition, right? Probability of yes given sunny we call it, right? So wherever it is sunny, is it yes or not? That's the count we need to take. Yes when it is sunny, given sunny. Okay. Probability of yes given sunny. So it's going to be 2 by 5. Probability of no given sunny is going to be 3 by 5 because there are only 5 occurrences of sunny, out of which 2 are yes. So 3 are going to be no. Right? So by looking at data, you can actually calculate that. Like that, you calculate the conditional probabilities and the individual categories probabilities for each of the columns, each of the categories in the column, and calculate the Gini index. Whichever Gini index is low, right, that's the best feature. Basically, Gini index calculates the impurity. Did I talk about impurity? Did I show you the cross entropy, the balls and the bag, the coins and the bag? I think yes. Let me try to go to the slides. In multi-class classification, see this is, now here we are using cross entropy, right? Even in tree algorithms, we will use cross entropy also. Gini index or cross entropy, one of these we'll use. Okay. So what cross entropy is calculating impurity. Here it is more impure. The decision making is difficult. It is less impure. The decision making is a little more, easier, right? Because blue coins are more. When you take random coin, right, most probably you get blue coin. So when you calculated impurity using cross entropy, you are getting a big number for this where the decision making is difficult. You are getting a small number where the decision making is easy. Right? Impurity more, impurity less, right? That's the thing here we are using. Impurity less, that means that's the using that feature you can make decision more clearly. Getting it? Less impurity, you can make decision more easily. The feature is more important. Getting it?
Yes, sir. Yes.
Right?
Yes, sir.
So that's the key. You know, these are all interrelated. You know, one concept comes in, it will be used in many other places. So you know, so we are calculating this column's impurity, which is 0.1714. This column's impurity, again probability of hot. Right? In this column, we have hot, mild, and cold. Probability of hot into conditional probability of hot, right? Whatever. Right? And then we got 0.2201, 0.187836. Out of all these, the impurity for outlook is less. So that is the best feature, we can say. Okay, this is how the algorithm actually chooses which one is the best feature. Okay, and here there is a concept called as Gini gain. Using Gini index, you can calculate. You know, you can find out the best feature. But Gini gain actually looks at a probability. You know, Gini index of the target variable minus individual Gini indexes, individual columns Gini indexes. Play tennis is the target variable minus Gini index of outlook. Play tennis, Gini index of temperature,